Welcome everyone to this webinar hosted by Toradex entitled Mixed-Criticality in Safety Critical Avionics and Defense Communications with NXP i.MX95 and SYSGO PikeOS. So it's a mouthful, but hopefully actually this is of interest and you are here in the right place. So the topic of today is about aerospace and defense applications demand. So these applications are actually very demanding in terms of rapid iteration and uncompromising safety. So in this joint webinar with our partner SYSGO, we'll be showing you how to achieve both basically iteration, like a rapid iteration, and this safety on the new iMX95 based Toradex modules. So I hope this is actually of interest, and we have great content for you today. So my name is Carlos Gonzalez. I am the head of partnerships at Toradex, and with me, I also have Stefan Wagner, who is research and technology engineer at SYSGO, which is a Toradex partner. So before diving into the content of the webinar, let me just cover a few organizational points. First of all, please use the chat window of the webinar tool if you have any technical issues, if there's something that doesn't work for you, and I will jump in, try to help. At the very end, we will also have an interactive question-answer session. So you can type your sessions in the chat window at any time, and then we'll pick up the questions at the end and answer them. So this webinar will be recorded and made available for on-demand viewing. With this, let's get started. So just let's have a quick look at the agenda for today. So first of all, we're going to have a look at Toradex in a nutshell. So what are our credentials in the aerospace and defense sectors? Then I will hand it over to Stefan to demonstrate how PikeOS offers very strict partitioning, the deterministic performance, and a very clear path to relevant industry certifications. Then we'll look at the iMX95 platform, which is now supported by PikeOS, and we'll look at the specifications, and then we'll look at all the different families and the roadmap. And finally, we'll just look at what is the value that we are bringing to customers together with SYSGO. So let me just get started actually with Toradex. So as you may know already, we are a Swiss-based embedded computing company. We offer ARM system of modules, which are basically known for their reliability and the long-term maintenance. So we, for example, have a very wide temperature range from -40 to +85 degrees Celsius. In addition to SOMs, we also have carrier boards, which are off-the-shelf carrier boards that you can actually use for development and also for production purposes. We provide the design files for these carrier boards in case you want to customize them. Also, we have the ability to tailor these carrier boards and essentially produce end products. We have a new division for volume manufacturing, so we can actually take care of the whole product life cycle for you, even producing enclosures, connecting peripherals, and essentially complete end products. But actually, one of the main reasons why customers choose Toradex is because of the software support. So we support operating systems off the shelf. Essentially, you have ready images like the Yocto-based BSPs, but we also have our own embedded Linux distribution, Torizon OS, and then on top of that, we have this IoT platform called Torizon Cloud. So we'll get into that a bit more. But I think the key thing here is that we support as well third-party operating systems like PikeOS, which are very relevant for this specific use case that we'll be talking about today. Also important to point out is that although we have Swiss roots, we are a global organization which has a manufacturing in Europe and also in Asia and America. We enable customers to comply with avionics and defense requirements, including the International Traffic in Arms Regulations, ITAR, which is US legislation that controls the export and import of defense-related products. So started already, we have actually manufacturing in America for customers that wish to have that ability. So why are we working with SYSGO? So we actually started working with them over a year ago to bring the power of PikeOS to the NXP i.MX platform, starting with an iMX95. So with this collaboration, we want to enable customers to use the same hardware for 2 life cycles, essentially. So we want them to prototype very quickly, maybe actually starting with Linux, and then log partitions and certify using the same code. So essentially allowing them not to reinvent the wheel when they have to go through certification. The good thing of using the system module platform that we have is that it speeds up your time to market, and it lowers the upfront cost and risk. So essentially, you can actually get something that is already ready for you to start developing and iterate. So that is actually a great advantage of using a Toradex hardware for immediate prototyping, essentially. We also offer a frictionless migration. So, once you actually have validated your applications in prototype, you can move to production very quickly with our hardware. Since recently as well, so SYSGO has enabled a BSP, a board support package for the iMX95. So you can actually just get started very quickly with it. So before we continue, let's actually start our first poll. So I just wanted to actually ask you guys to give us some information about your existing project. If you are working on a project about avionics, defense, HAI, industrial, or even others. If there's anything that is not listed here, you can even put it on the chat window. So yeah, it would be great to get your feedback. And I'm actually assuming that it will be evenly split between defense, avionics, and industrial, but I may be wrong. So just give you a couple of seconds, and then we'll actually see the results, and I'll basically take advantage to hand it over to Stefan to get more information about the use cases. So avionics, that is great. I think it's one of the reasons why we have SYSGO here, because they have a strong background on this specific use case. So yeah, over to you, Stefan, if you want to actually tell us a bit more about SYSGO, PikeOS, and use cases specifically.
Hello from my side, and thank you. So when we look at possible use cases, we see you can use PikeOS on the iMX95 board for situations where you need safety or security. And you can use it to combine safe, critical, and non-critical applications on one board. For example, in a mission computer or in a flight control, you can combine it on an edge system to add some, for example, AI, image recognition or something. And this can execute without interfering the critical parts. And that's also true for security. You also can build up a system that you can isolate sensitive data and functionality from non-critical parts. Yeah, coming to SYSGO, our company was founded in 1991. We are an operating system vendor for embedded systems and real-time systems. We started in the avionics area and also work in all the other major industries. Our main product is PikeOS, which is a certified real-time operating system with a Type 1 hypervisor. We have also a Linux distribution for an embedded Linux, our Elinos, and yeah, a member of the Thales group. Yeah, when we come to our main product, PikeOS, this is an operating system with hard real-time capabilities and has a Type 1 hypervisor. It is built on top of a separation kernel, yeah, to provide these, we call it partitions, or you can say virtual machines. We call them partitions, and you can host guest operating systems in there, like Linux, Android, depending on the architecture, Windows. and also runtime environments like POSIX, iMX95, and PikeOS also has an own API what you can use to for drivers or for small applications. And with this approach, you can build up mixed critical systems that you have one or several partitions hosting safety or security critical applications. And you can combine it with a Linux partition running on the same hardware without certifications for this. You can use this, for example, for rapid prototyping that you develop your applications in Linux, and then you can distribute functionality, put it from the Linux partition into another partition, and then can certify it later if needed. And then you can get benefit of the safety and security features. We support all major architectures, and we have multi-core support. For the certification for safety, we have certificates for, or have done projects in all kinds of industries with all kinds of standards. For example, in avionics, we have projects where PikeOS was certified to DO-178C A. And for security, we have a common criteria ERL5+ certification. And we provide certification kits to customers when you need or want to do certification projects, that you get special support from us and a lot of documents you need. We will talk about that later. For multi-core support, we have PikeOS is AMC2193 compliant. And therefore, we have ways to control the caches, memory accesses with DMA, the interrupt handling in the system, and of course you can control or define the behavior of the scheduler and the interpartition communication in the system. And all of this is certified to the highest security and safety levels. For the multi-core management, we have scheduling possibility that you can assign partitions to separate or to special CPU cores, and you can define a time schedule. We call it time partitioning to define which partition is active in which point of time on which processor. So you have really deterministic behavior in the system, and also a very abstract view on the system that that it's easier to certify, to see what processes are actually running at the point in time. You can use PikeOS for symmetric multiprocessing and asymmetric multiprocessing. So depending on your requirements, what you want to achieve, you can use both approaches. And we provide also some certifiable components you can use, like a network stack or file system. For the certification kits we provide, we have a modular approach. That means for all our components you get with PikeOS, we provide you the certification artifacts, for example, for the separation kernel and for the hypervisor and for the APIs. And in a certification project, you can reuse these documents directly. And so customers can then write their critical applications, for example, in iMX95, and just have to certify their code. And maybe depending on the hardware, the platform support package describing the board. So if you have an own board with own IP, you will not give out to someone. You can provide the platform support package for that board. And of course, this has to be certified then as well. And what you see also in this picture here, if you have other partitions next to certified partitions, this doesn't break the certification. So it's independent, they are strictly isolated, and this is ensured that the critical applications do not get disturbed by other stuff which is going on in other partitions. When you want to implement small applications on PikeOS without a full operating system. Of course, if you use Linux, then you have Linux, you can develop with everything what Linux is capable of. But if you want to do just a small application, you can use, we provide support for C and C++. For the POSIX API runtime environment we are currently preparing, and we call it next generation with improved scheduling capabilities. And therefore, there we will have a certifiable standard template library for C++. And you can use Rust to develop applications. And of course, we have an IDE to support you with this. We call it, it's called CODEO. It's based on Eclipse. And there we have a guided configuration. You can use the debugging framework of Eclipse. You can get runtime information of the target running, so see what partitions are active, what resource consumption is used by which partition. You can get timing analysis of the applications running there, and you can for debugging during development you can deploy applications in a partition and run them there. Okay, now that we want to do another poll. So question now is, do you have mixed criticality needs in your project?
I think this is going to give us a very interesting result. Maybe people don't have the needs yet, but maybe they are thinking about having these needs in the future. But yeah, I'm very curious to see where's the result here. All right, so that kind of makes sense, right? Otherwise, they wouldn't be sitting in this webinar. 70%.
Okay, then we want to present a small demonstration of our tools. So yeah, I want to present how to work with our tools to make a very small example of PikeOS running on the iMX95 board. We see here now a PikeOS, the configuration of the base system. We call this is an integration project where we select the board, the BSP to use. And there we can now define the applications, the partitions which are running. And here we have one PikeOS partition, which uses the API of the microkernel. And of course, we need something which executes in there. So I create a very simple application, which will be loaded inlet partition. So I clone an application project now. And we see it's a very simple hello world example. Yeah, I will change the output that we see that the program which is executed is really what we just compile. So I compile this binary and install this in we call it a pool where the integration project can reference it, so we don't have to change paths for this. So now I create the boot image and install it on a TFTP directory, and then I reboot the iMX95 board. It loads the boot image via TFTP, and we see now boot messages of PikeOS, and then we have seen the hello world message. It was very fast, but it was possible to see it. Now I create a connection. We call it so Eclipse has a way to connect to remote targets. So I have now a connection to the target, and here we see the connect to our monitor tool, and then I can stop and restart partitions. On the right bottom, you see the serial output of the board. So we see the partition has restarted and has printed some the hello world message again, and it prints every 5 seconds the string. Now I add a Linux partition that we can add a Linux kernel also to that scenario. I have to give it a unique partition identifier, and this preset here defines also a memory which is given to that partition to the kernel. We have to give it access to network that we can access, or Linux will then get a separate network access. And of course, we need then a Linux kernel. So I will use our Elinos Linux distribution to create a simple kernel with a network server, with a web server, and we can put this, provide this into the partition, and then we have both partitions running at the same time. So here I select, of course, the board support package for Linux. I select the one to run on top of PikeOS. Of course, you can also run Elinos native on the board. Now this Linux project is cloned into the workspace. We have some, we call it features, that you have a simplified access to the configuration. So I define, or have to define the network addresses here. I will add a web server and an SSH server that we can connect. I skip the compilation of that kernel in the video here. I've precompiled it because compilation of Linux kernel takes some minutes. Yeah, so you would say make install in the Linux project, and now I built the PikeOS project with now two partitions in it, so the Hello World partition and the Linux partition. Yes, we see the TFTP boot. Now the boot image is much larger, and we also see now boot messages of PikeOS and then also some messages of Linux. Put it back in the right lower corner, and we see the PikeOS partition is printing Hello World, and I can connect the terminal to Linux, which is running on the second partition. Yeah, and we have the small web server, so that we have some very small web page prepared here. So I can load it in a web server, and this video capture was a bit too small, so I have to scroll. But you see the web server is presenting some web pages, and yeah, this is running on PikeOS together with a Linux partition. I think, Carlos, you can take over.
Yeah, that was great. Thanks so much, actually. So I was impressed how easy you made it look like. Yeah, I guess that is a bit harder when it's the first time you do it, but with your experience, actually, it just looked like very seamless.
Yeah.
All right.
Good tutorials.
Yeah, I can imagine, and I'm sure that you are at hand to help customers actually
yes.
do so. All right. So now that we saw the software side of things, let's actually take a closer look at the hardware. So the iMX95 is a new chip from NXP that we actually see as a normal evolution to the iMX8 platform. So we have actually a broad portfolio of iMX8 and plus products, and we see that customers are very interested in the 95 as the normal evolution. And it's a great fit for next generation applications like aerospace, avionics, defense, and industrial applications. So this chip features up to 6 ARM Cortex-A55 cores, in addition to 2 microcontrollers, which are actually in an independent safety domain. So this Cortex M7 and Cortex M33 CPUs can actually enable real-time processing and very high power efficiency. So that's why it makes a lot of sense for companies like SYSGO actually to focus on the 95 because of this heterogeneous infrastructure. It also has a very rich set of high-speed interfaces like this 10 gigabit Ethernet and automotive Ethernet. So it's also a very great product for automotive customers. And the i.MX95 family integrates secure enclave as well. So it's basically streamlining this critical function like a secure boot, cryptography, trust provisioning, and also the runtime attestation. So it's essentially simplifying the whole cybersecurity compliance, and it makes it very easy actually to comply with regulations such as the upcoming CRA, the Cyber Resilience Act in Europe. So it also has a very powerful Mali GPU, which is actually part of the real-time domain. So you can have critical information in safety or like real-time applications, like leveraging the GPU. And finally, when it comes to display, multimedia, and also machine vision capabilities, so this product comes with a built-in Neutron MPU, so you can run computer vision applications with multiple cameras and an integrated ISP, so image signal processor for advanced vision tuning. So essentially, it is a very well ramped up product, and that's why we're getting a lot of interest from customers. And actually, a testament to that is the fact that we actually have 3 families already supporting the i.MX95. So from the very top, you can see that since 2024, we have an evaluation kit. So our Verdin evaluation kit, it is mainly for obviously evaluation purposes, so it's not a production ready product, but has been enabling a lot of customers just to test and to prototype. It comes with a SOM and also a carrier board, and it will continue to be available for some time, but we'll basically phase it out at the end of this year. Recommend customers that start actually testing directly on the production ready products, which are the SMARC iMX95, which is already available in sample stage, the Verdin iMX95, which is I guess the small factor family is our wider range compatibility family. And finally, the latest addition is the Aquila. So the Aquila iMX95 for any high performance applications. It has a very extensive interface set with a 400-pin connector. So essentially, you have a very wide choice if you really want to actually develop with this particular chip. So I will not really dwell on the specifications. That's a lot of data in there, but I just wanted to show the comparison of the different form factors, so you can see actually how they compare with each other. Maybe something to point out is that the Verdin has a 15 by 15 chip, so it is actually smaller than the other ones. The Aquila SMARC, they have this 19 by 19, so it's a bit bigger. So it's actually a very nice fit for applications that require small size, which probably is the case in some of the projects that you're working on. So we'll have another poll right now just to get a bit more information about what kind of hardware or platforms you are planning to use on your project. So again, I'm just going to assume that there will be a lot of people that are joining this webinar because of NXP, because we were talking about the i.MX95, but it may not be the case. Maybe some of you guys are working on Qualcomm or NVIDIA or maybe something else. So feel free to drop in the platforms that you're using. And let's actually have a look at the results. Let's see what is the outcome. Yeah, not surprised here. Actually, this is a almost perfect split among our customer base, because we also have TI products in our portfolio, but it's primarily NXP products. So yeah, thanks for giving us your feedback and sharing with us the information about the products that you are planning to build. All right, so let's jump a little bit on the software side of things on the Toradex front. We are a hardware manufacturer, so Toradex is mainly focused on the hardware, but we also provide as production-ready operating system, which is Torizon. So it is a free open source operating system and also on top of it offers an IoT platform for industrial use cases. So it comes with an automotive grade update client to allow very safe software updates, over-the-air updates. Securities are very focused for Torizon, so we enable customers to actually do very frequent updates using our platform. And essentially is built with the Yocto project. So we utilize Docker for containerization of the applications. So it is actually quite interesting to use a Docker container to isolate the application from the operating system and maybe from other containers or application. That is actually quite handy as well when it comes to certification, because you can actually isolate the different applications within the operating system. All right, so just to wrap up, just to put it all together, what we discussed. So first of all, the reason why we are collaborating together with SYSGO is because we want to ensure that safety and security is offered to our customers by design. So we are combining a very secure and solid Linux solution together with a real-time operating system, both for non-critical and for critical applications. And it's all on the same hardware. The ability of running different operating systems in different partitions and different event cores. So you can actually get to that level, controlling the interfaces at the level of the operating system and the partitions, I think is actually very valuable. Also, to reduce the swap and the cost. So essentially, smaller in size, lighter in weight, and then they also consume less power. And this is really, really relevant, I know, in aerospace, defense, and drone, tactical gear, these kind of applications. So the physical constraints and the power consumption are really, really important. Also, trusted connectivity, the future-proof flexibility, and eventually allowing you to have a fast certification and deployment path. So that's the reason why we think that the solution of PikeOS together with Toradex hardware makes a lot of sense for your projects. So with that, I think we can actually jump into the Q&A. So I will just quickly open the questions to see actually what questions we got. And I'll start, yeah, so we got a couple, right? So I'll start with this one is, so how easy is it to migrate existing applications to this architecture without starting from scratch? So that would be the first question. So I guess maybe I can take from my side. I think migrating is very doable. So it is easy in the sense that actually we provide, at least from the Toradex side, we provide a lot of resources, both on the developer side and also from our sales team. You actually need any support. So it allows you not to rewrite everything. So I think it is actually quite possible to migrate your application to our platform, but it all depends actually where you're coming from. Actually, so I think here we just probably need to go a bit deeper into what is the where you're coming from, what are you migrating from. But I think from our side it's relatively straightforward.
Yeah, from PikeOS side, from our side, but we are very flexible. So as we have seen, we can use asymmetric multiprocessing or symmetric multiprocessing. So you can, in the easiest way, have some core executing the legacy code and the other cores running other applications. You can put it, if it's Linux-based or POSIX or iMX95, you can easily put it in a partition and run it directly, or you have some porting effort to migrate it to the PikeOS API. So it depends on, as always, on the requirements. But it's very doable, yeah.
Good. There's another question, a very specific question. I think this is good. So should I need to assign dedicated hardware resource for Linux and PikeOS? For example, number of CPU core, dedicated memory. So do you actually need to dedicate the specific hardware resource for each of the partitions?
Yes, you have to, because otherwise we cannot guarantee for the worst case execution times and for the safety requirements. So we have a static configuration in PikeOS, and you have to do the configuration before the system is built, and then it will never change at runtime.
All right, good answer. Let me actually have another look at the questions. Yeah, so how does PikeOS ensure safe separation between critical and non-critical applications on the iMX95 SOM?
Yeah, we have this time partitioning, we say it, so we can define which partitions are allowed to execute on the CPU cores in which point of time. And if you assign the critical application some time partition here, then PikeOS really guarantees that it's certified that only this partition can execute in this point in time. So you have to define the schedule, and then it is guaranteed that this will not be broken. So there's no interference.
All right.
And also for the memory resources, we have what I've said before, we have a static configuration of all the resources, and it will not change at runtime.
All right, good. So I think we have a follow-up question from a couple of questions before. So what if PikeOS? Right. Let me actually read this. Okay. So what if Pike is using a few GPIOs from bank one and a few being used by Linux from the same bank? How can you actually handle the scenario where they're using the same GPIO?
If you want to separate this, then you would need a separate driver controlling the hardware and having a virtual interface with only the assigned pins to the different partitions. But then you will need an additional step in between.
Got it. And what is the mechanism to communicate between PikeOS and Linux? Is there actually any channel between them?
Well, it depends. If you use para-virtualization, that means the Linux kernel knows that it's executing on PikeOS, then you can use a trap interface. And if you use hardware virtualization, then we have some specific device drivers. So you have so Linux will call some device and communicate with this.
All right. And actually, yeah, another follow-up question on that. So can we reschedule, or can we schedule any activity from Linux which is going to run finally on PikeOS? I guess can you actually switch activities from Linux to PikeOS?
You have, if I understand it correctly, you want to have some Linux application and then you want to execute it on PikeOS directly. Is this the question? The
way I understand it is that maybe you schedule some specific application, maybe some action on Linux, and then you want to actually transition and migrate it to PikeOS. Is that even possible?
Yes, you have to. Yeah, you have to migrate to the PikeOS API then, or POSIX. You can use POSIX, for example. So to develop the Linux application in POSIX, and we have a POSIX API. So you have to mostly recompile. Of course, some small adaptations would be necessary, but that would be the easiest way.
Got it. Yeah, I think. I mean, I have my own question about this. So what if you actually want to make changes on the go, right? So basically, you design your infrastructure statically, right? And then you install it. But if you actually want to make changes once the product is on the market, is that possible, or is it basically just sitting on and static for the life of the product?
Well, we have over-the-air updates possibilities, but that depends on the project. So what do you want to update and how?
Okay.
Essentially,
so you have to.
Yeah. You have to exchange the boot image, let's at least, and reboot. But we have ways to do this.
Good. All right. So another question is, all right. So is the Toradex board, the iMX95, so it has the hardware acceleration elements besides the CPU, NPU. So how is PikeOS planning to support hardware acceleration? Is that supported by PikeOS?
Yeah, I would say from operating system point of view, this is just some memory, so some device, and which can be mapped to a partition. So the application is responsible for this, but it can be used.
Mm-hmm.
It would be more complicated if you want to virtualize it. Then, as I said, we would need some driver.
Got it. Okay. And what is the level of POSIX support in the PikeOS for Toradex? So in particular, what about pthread for multi-core applications?
We provide the PSE 5.2 profile for POSIX. So this is we have pthreads, we have, but we don't have users.
Got it.
Yeah, file system is supported, and yeah.
All right. So many questions, actually. I'm just trying to digest all of them. Yeah, this one, I think it is, taking a step back and looking at certification. So can mixed criticality designs like the one that we just described simplify compliance, or do they make audits more complex?
It can simplify because it is so strictly separated that you can leave the uncritical parts outside of the certification process.
Mm-hmm. But I guess that you need to be very thorough for the certification, because so it adds a bit of additional work, but it makes the whole process of certification easier.
Yes, you have to certify the configuration. This is part of the certification project, and then if you have done it correctly, then you don't have any interference, and then you can just certify the critical parts, and the other criticality levels are you can leave them out. Yeah.
All right. Good. So I think we went through all the questions. There were a couple of questions that were already asked and answered, so I'll skip them. But I think if there is no further questions, I think I would just like to thank you, Stefan, for your time, and the audience for your attention. I personally learned a lot, so hopefully you did as well. Yeah, very much looking forward to seeing these projects that you guys are working on, and hopefully we can support you with our hardware and also with PikeOS. So thank you, Stefan. Thank you so much.
Thank you.
Bye-bye. Cheers. Bye.
Yep. Goodbye.